Hi, I'm James McGuire, editor-in-chief of eWEEK, and today we're talking about how the explosion in data and artificial intelligence is fueling the need for more memory and compute. To discuss that, I'm joined by someone who knows a lot about the topic. With me is Raj Hazra, Senior Vice President and General Manager of Micron's Compute and Networking Business Unit. Raj, thank you very much for joining us today.
Hello, James. Thanks for your time, and it's a pleasure to be here.
Well, certainly. I mean, I've got some great specific questions, but it's a field that's seeing an enormous amount of growth and change at the moment. Correct? I mean, I would think simply keeping up with it requires you to really be on your toes.
Absolutely. We're in the midst of a phenomenal change as the availability of data transforms almost every aspect of our life, James, whether it's in how we study, whether it's in how we work, it's how we play, how we take care of ourselves, how we communicate. Data is really the foundation of the knowledge economy, and we're seeing its impacts in every aspect of our lives, even as we talk to each other on Zoom today.
Right? Isn't that amazing? So my question is, what are some infrastructure changes that are needed to really make the most of data and really mine the most insights from data? What are the infrastructure changes that you would recommend?
It's a great question as the amount of data, and there's not just big data, that's lots of data, but there's also fast data, right? Data that you have to consume in a given amount of time in order for the insights you generate from it to have value, right? So if you look at infrastructure comes in along three categories, which is part of where you store the data. The second is kind of where you compute on that data.
Right.
And then, of course, you have to have data movement in order to facilitate where the data is collected, stored, and then eventually computed.
Right.
And I think also three aspects of those of that infrastructure element will change. The first is the compute side, and a lot is being said about it, and it's probably the most visible part of it is going to have to change. More energy efficient compute. As you have more compute, energy efficiency and performance become really important. So more performance, more energy efficient performance, more what I would call AI tuned architecture, computational architectures. You started to see that as general purpose compute got augmented by what we call GPUs or accelerators, and now we have very function-specific ASICs devoted to doing some very specific tasks of AI very well, very efficiently, very powerfully, and that part of that compute infrastructure has to continue to grow. But probably
just a short point on that, if I may, because I love the idea, and you've talked about it a little bit, the idea of an AI-tuned infrastructure. Could you talk a little bit more about that? Because I think people would be really fascinated by that.
Sure, and that's you can't talk about an AI-tuned infrastructure by only talking about the compute and its evolution, or some would say revolution.
Right.
For AI optimized infrastructure, you have to talk about the balance between compute and data memory intensity, right? And what do I mean by that? As these compute engines get more and more capable, they are starved if you don't feed them, if you don't have enough data storage near the compute, and if you don't have enough bandwidth in order to get that data into the compute as fast as needed. So memory capacity and memory performance have to keep up with the kind of spiraling growth of compute. And in many ways, that innovation, the memory side innovation, has to be almost as fast, if not faster, than compute. And the reason is the rate of data and the benefit derived from data is growing exponentially. If you look at models that are used in AI training today, I mean, people are at billion parameters in a model today for things like natural language processing. And you think that
to be sure, AI is very data hungry. It's just like it devours data.
It lives in data, right? I mean, without data, we would not be talking about AI like we do today. AI is kind of the fuel that feeds that fire in a good way. But you're talking about a billion parameter models for fairly, decent tasks around, say, natural language processing or computer vision. But algorithmic researchers are seeing how much more efficiency and how much more effectiveness and how much more insight you can generate if you go to 1 trillion parameters. And those algorithms are ready today. So now you have to
Oh,
see not only the compute improvement, but the memory side improvement to be able to hold and feed a compute engine with 1 trillion parameters
wow. Okay.
many,
Yeah.
many times over as the system learns, predicts, tests, predicts again, right?
Hmm.
So,
Mhm.
so the data explosion is one where, of course, there's going to be growth in compute, but the memory side infrastructure, you asked the question of how does AI optimize infrastructure change? The
Right.
memory side infrastructure, the first thing we notice is not only has memory to get more performant in terms of higher bandwidth, delivering capacities, but the growth of a hierarchy, a memory hierarchy, where you
Mhm.
can move the data closest to where the computation is going to need it, and then move it away to make space for more data that is now more needed,
Mhm.
right? This notion of a memory hierarchy where you can shuffle the data and choreograph and marshal the data and keep it at the right place. So you have the most critically needed data for now, closest to the compute, and then that data can move back and forth as the compute needs it.
Mhm. It
Is the
never
heart
fails
of
to.
the AI infrastructure.
I'm sorry. What's the last thing you said? I
That
don't
is
want
the
to cut you
heart
off
of the
there.
infrastructure, is that compute and memory hierarchy that is balanced.
Okay. It never fails to amaze me that companies they have oceans of data. They have just torrents of data, and they usually have more data than they know what to do with. And the truth of the matter is they end up tapping actually a minority of the amount of data they have, a smaller percentage that they have to actually get insight from. I mean, they have way more than they really mine. Why do you think it is that companies are mining a fairly small percentage of the total data they have?
And that's a great question. I have lots of CIO friends who have told me, even fairly recently, is data a blessing or a curse?
Right.
Because
Yep.
if your data is not being used,
Yeah.
it's really holding up resources, mainly in storage.
Hmm.
But I think that to the question that you asked, even in the last few years, as you see advances in the infrastructure and the algorithm, you're seeing what the reasons are. Number one is you need to have the computational infrastructure and the data infrastructure to be able to make that data useful,
Hmm.
right? Not only do you need to have all of that data, but you need to have a data infrastructure that lets you pull that data, compute on it, right? So the growth of the infrastructure to keep up. The second is growth of algorithms, making algorithms go from research labs and papers to actually being used and deployed every day.
Hmm.
And third is a cultural element of organizations learning and accepting that what you was done differently before can now be done with a technology called artificial intelligence, right? So all
Did
of those three things have to happen. The infrastructure that has to expand, has to advance to
Mhm.
be able to handle the needs of these enhanced algorithms. And culturally, organizations have to adopt those into mainstream and move forward with those as the new normal versus
Right.
how things were done before.
On that cultural piece, do you think it's a question of either A, sometimes the executives still want to run the business by the seat of their pants because it's really how they've always done it, or just by gut instinct that is, or is it they haven't hired enough data scientists because data scientists are really expensive? I mean, what's slowing down that cultural piece in your view?
I think I think fundamentally this is a big change in how we operate, from human driven policies to much more of a data centric, analytical, predictive infrastructure, right?
Hmm.
The roots of the answer to the question lie in some of the things you mentioned. You need to have enough of that talent on board to be able to have real domain specific problems being solved in reliable ways that you can turn your business and run your business on, right?
Hmm.
The second is you must have enough data. The third is you must have enough data and compute infrastructure to be able to do that reliably, repeatedly, and scalably. So I think, like any change, it does run its course, and we are seeing an acceleration of that course in the industry. About in a short matter of 3 or 4 years, we are going to see about 90% of enterprise applications use AI. What does that really mean?
Oh.
It just doesn't mean that what it does is AI, but it means that artificial intelligence techniques are used in just how it does it as well, right?
Hmm.
Making predictions instead of older methods and statistical methods to data-driven methods,
Hmm.
improving even the execution of that application using AI and a knowledge of what's running well, what's not running well. So I think that this movement, if you will, this change will touch many things in the ecosystem, and that's why change is good, but sometimes change takes its time to not only to envision the future, but to enroll all elements of it in that journey.
It's really interesting the 90% figure you used, and that it
That I
seems
believe is
today.
an IDC figure.
Is it okay? All right. I mean, from where I stand, it seems certainly optimistic in that I think the current figure. I mean, I hear mixed reports on this, but the current figure might be 5 to 10%. So if we get to 90 in the next 3 or 4 years, you never know. It depends how they define it, but I also hear a lot of disillusionment with AI. Like sometimes it's an expensive science experiment that doesn't really come to fruition. People are not really sure how to get the most of it. But do you sense there's a certain sort of struggle and frustration with it? Or do you think it's just really pure movement upward at this point?
Yeah. Before I answer that, let's just be very clear on the stats I quoted, right?
Please, please.
90% of enterprise applications will be AI enabled, right?
Gotcha. Okay.
Not
All right.
90% of the data will be used. In
All right.
fact, the value derived from having those applications be AI enabled will only increase as there is more and more useful data being created to serve those applications. So
Okay.
I just want to make sure we didn't misunderstand each other on that.
Yep.
Like any technology, it and AI has generally gone from POC experiments, trying to figure out whether it provides a benefit or not, to mature kind of productization in the enterprise. Um, has been an accelerating journey, and I see so many positive examples of organizations finding a way, once they deal with the challenge of the data, of unstructured data lying in heaps in the organization, getting a data architecture and a data lake in place. You see
Right.
organizations hiring chief data officers. That role didn't even exist before.
Right.
But getting their data in order, their data house in order, really making some gigantic leaps in the productivity in their business, but also their ability to get into new sources of value, not just the same set of things just done better, but a new set of things. So generally, I think there are still some challenges with deploying AI, but AI has proven its worth and its potential and its ability to be a strategic enterprise differentiator pretty solidly.
Oh yeah, I would definitely agree. I think there's a sense. I think executives and managers realize if we don't get on board, if we don't keep investing in AI, we're going to fall behind. It's not optional. It's it's absolutely essential competitive element at this point. Um, but let me ask you this. So say we go ahead, we make the progress that we would expect to make. We're getting more insights from our data. We've got a better, more efficient infrastructure. What will be the business outcomes? What real advantage to the bottom line is that going to reveal?
You know, in some ways, it is almost hard to predict. And if you could
Mm,
predict, I would say we would have a limiting view of AI. It's
mm,
almost like 2 decades ago saying, what would you, when PCs were 300 megahertz, saying what
right.
would you do with a gigahertz PC, right? I've lived it in that era and that question.
Hmm.
Um, I think the answer to that question lies in the early signs you see in its use today. Organizations are using it to dramatically improve R&D proficiency. They're using it in smart manufacturing to improve the reliability of products. They're using it to do their supply chain, customer relationship management, a much more intimate kind of knowledge and connection with their customers. They're even using it for talent searches. As human talent becomes a critical business differentiator, using AI techniques to really find that talent and train that talent to what they need. So AI is pervasive. I mean, we could go on and about successful things from everything from precision medicine to societal things like modeling entire financial systems, to healthcare. Many examples of things in healthcare, weather prediction, climate modeling. The point is very simple. Whenever you have data, I think of it this way, James. Our analytical techniques, where we express the relationship of things in the world with equations, is a limiting view, because we have only, even though the humankind has been so brilliant, we've only been able to decipher a few of the physical phenomena and make equations to express it. The rest of that universe lies in data and relationships we can't model mathematically. And AI unlocks that space where the human mind still hasn't been able to analytically define it and therefore predict from it into an entire domain of value.
Can you, I think it's a really fascinating point. And I don't know if you could elaborate on that in terms of, is there a way to give an example of that, or it just would be too hard at the moment? I'd love to find, I think it's a really fascinating point. I'd love you to elaborate on that a little bit.
Yeah, no, that's again, it's one of the things that I think is fascinating about data-driven science, right? It's really the next paradigm to experimentation. Think of causalities which you could never express in closed form, as some of us ex-mathematicians would call. These are outcomes that are defined by elements, and I'll give you an example, that do not have an equation, so you can't give it different inputs and see what the outputs are. How do you correlate weather phenomena to physical phenomena, to stochastic inputs, and determine if a particular event is happening or not, right? How do you take data that's lying there with no apparent correlation and correlate that to find an insight of X, Y, and Z make P and Q more likely than ever before, right?
So you can't do that in this case.
Yes, of course, we can do that with AI. And as as we go from kind of the supervised learning era of AI, where you basically tell the AI engine, and proverbially you show it the cats and say, that's a cat, that's a cat, that's a cat, and then it learns to recognize a cat. With things like reinforced learning, you're not even held back by availability of data. It learns on its way, just like you and I learn, right? And tests and make mistakes and corrects itself and learns. So that's called reinforced learning, and you don't need a mass of data and a teacher to train it. When those kinds of things happen, you are now modeling the world in a much broader way, in a phenomena-specific way than equations that express physical laws and relationships between objects. And that opens an entirely different sphere of insight generation. I mean, a simple analogy is, if all you had was the ability to draw straight lines and you had a mass of points on a graph, all you do is draw straight lines or do piecewise linear. And if you had more sophisticated ways to model, then you'd get to nonlinear curves and other kinds of ways to establish relationships. And data-driven AI relationships says you're not constrained by any degree of polynomialism, right? I mean, it is what the relationship is in the data. It's the ultimate form of making sense of multiple things and driving predictions from it.
Well, that's wonderful. I want to give you a chance before we go to make any comments about the Micron product roadmap. Anything you want to add about something that's coming up or development in the Micron product feature list? What should we know about that before we go?
I think in closing, I would just say, that we at Micron here are sitting at the heart of this AI revolution and working every day to understand how to make memory and storage more performant, how to drive different system architectures that make AI computations more efficient and effective, We continue to work with the ecosystem to evolve standards like CXL and JEDEC standards around DRAM. But what we really do here is ensure that those innovations find their way into markets through the hands of our customers, so that some of this promise of what could be done if we had the right infrastructure is realized sooner rather than later. We have an exciting slew of new product announcements that we will be making in the immediate future. And I would just say stay tuned for that.
All right, great. I think it's going to be fascinating. I mean, certainly we do need that improved infrastructure because there's an enormous amount of data we need to sift through. So it's going to be interesting. Raj, thank you very much for sharing your expertise. I'll send you the link when it's done. Thank you for being on.
Thank you, James. Thanks very much. It was great chatting with you.